Сегодня поговорим про читинг и методы борьбы с ним. Вот, с утра уже мы немножко здесь немножко почитили. Очень большая очередь была к торговому центру. Мы решили, что не будем стоять в очереди и пройдем, иначе мы просто не успеем к этому докладу. Вот. Сегодня наш доклад мы расскажем о том, какой мы античит разработали для защиты онлайн-игр, таких как Unreal Tournament. Мы разработали защиту против мощных коммерческих античитов, которые существуют для ряда популярных игр, таких как Battlefield, Unreal Tournament, GTA. И мы расскажем, как мы пришли к этой идее, какие плюсы, какие минусы нашей защиты. К сожалению, мы не можем сказать имя читмейкера, этого читмейкера, из юридических соображений. Лицензия нам это не дает сделать. Но, те люди, которые этим заинтересуются вопросом, не будет сложно найти.
Terms and conditions. However, if you're interested, it will not be very difficult for you to find those cheats.
Почему же люди любят
Why do people love cheating? Cheating comes in different flavors, in different areas of our life. Some athletes, for the sake of big money, dope themselves with performance-enhancing drugs.
Также читинг и в онлайн-играх распространен уже с самых первых компьютерных игр, как Doom, появились читы, программы, которые дают явные преимущества в игре. Это может быть, чтобы увидеть противников через стену, чтобы поменять параметры компьютерной игры, бесконечное количество жизни, денег, патронов и прочее. Поднимите руки те, кто когда-либо использовал читы в компьютерных играх. Сколько же? Вот, почти. Статистика, кстати, говорит о том, что в России и в Украине высокий уровень читинга в онлайн-играх. То есть читинг для разных целей используется на самом деле. И для веселья, и для того, чтобы заработать деньги в любительских или профессиональных турнирах и спорта. С другой стороны, есть люди, которые заинтересованы в справедливой игре,
interested in fair play, and they do fight cheating. What I mean is that cheating, cheat makers earn quite a lot of money, around $1 million per year, and some of those earnings are reinvested in the development of new cheating software to compete versus new anti-cheating software products. Both developers and publishers of games are
и они заинтересованы в том, чтобы держать большую аудиторию, создавать большую аудиторию, заинтересовывать новых игроков. И потому что никто не будет заинтересован, если ваша игра будет страдать от читерства. Никто не согласится платить за месячные подписки, как это было, допустим, в Sims Online. Давайте рассмотрим несколько
Let's consider several examples. Examples of cheats for popular online games, such as the World of Tanks. The developer of war gaming created a dedicated directory for modified files, which include binary files for scripts, textures. In one way or the other, the developer encourages the developers to develop such things in order to find out about user experiences. In order to improve the client side, the developer
для удобного интерфейса в ангаре, чтобы прокачать свой танк, узнать информацию о танке, статистику.
GUIs for hangars to be able to see information about allies and foes, to analyze combats. On the other hand, there are forbidden modifications for which tankers may be banned. For example, textures that allow to identify vulnerable tank modules in order to make it easier fighting the foe, fighting the enemy. Another example is a cheat for the removal of or bushes here, the tanker in the tank believes that he is well protected. However, he is 100% exposed. And this is the second screenshot. The way it looks like, it looks the way it should. You cannot see the enemy. Another modification is a script that allows reloading tanks' guns, repair tanks on the fly. Another.
Существует скрипт, который позволяет автоматически детонировать нужное необходимое количество мин для уничтожения героев. Игроку даже не нужно заботиться о том, чтобы перейти на другую карту и нажать кнопку для детонации нужного количества мин. Скрипт делает все за него.
And here you can see cheating product for the Call of Duty. It is commercial product, and we developed an anti-cheating methodology for it. It is a commercial cheating software that allows to aim at enemies' personnel or equipment automatically. You can use 2D or 3D radars. You can see enemy troops behind walls. And the enemy's troops are depicted as those squares here on the screen. For you to understand.
Методологию, которую мы рассказываем. Большой обзор, кто такие вообще, кто борется с читами. Они очень хорошо известны. На одном сайте чита есть даже лицензионное соглашение, которое говорит, что если вы дальше перечислен большой список компаний, если вы состоите в этих компаниях или работаете на них, то вы не можете посещать наш веб-сайт, пользоваться читом и вообще как-то анализировать это. Для нас это было серьезно, списка
в списке мы не нашли нашу компанию, поэтому мы могли продолжать работать. Что же может чит вообще? Ну, два подхода есть основных. Это, вкратце, это работа на локальной машине и работа на сервере. Совершенно два разных подхода, они могут быть комбинированы.
They are two different approaches, although they can be combined. For some reason, in a game, you're in no position to use both, but they are independent. If you're working on a local machine, well, there are lots of methods to modify the gaming system.
Те же листья в танках брать через DirectX и так далее. Очень мощный, но по сути чит находится всегда в более выгодном положении, потому что это не время, как бы, да, то есть мы выпустили античит, его можно поанализировать, потом понять, как с ним бороться. По сути, основной минус таких решений, самая, так скажем, слабая точка, это то, что атакующий, ну, игрок, он, в общем, заинтересован, чтобы читить. То есть он владелец системы. То, что он владелец системы, это решает многое. Он более охотно будет давать разрешения на админские права для чита, может быть, какие-то действия делать необычные, ставить какие-то версии систем. Если чит работает на сервере, казалось бы, он лишен таких недостатков, у него принципиально другие методы работы, но основной минус такой, что он не имеет доступа к локальной машине. То есть на локальной машине можно делать все. Не существует вот из этих методов какого-то стопроцентного защищенного режима работы игры, никто не может дать гарантию. Ну, такой пример такой спорта, то как бы, есть такой новый допинг на букву М, который в велоспорте не то что...
Enhancement drug. Its name starts from the letter M and has been discussed for a while. Some time ago, bicycle riders were accused for using motors on their bikes. I tried to find out how much such a concealed motor with a battery would cost. Well, everything is 100% concealed. You will not see it on the bike with control button on the steering handle. What kind of lessons can we draw from it? Some time ago, a press release was published by the International Bicyclist Union about
достоверным, потому что появились новые моторы, которые более, что ли, лучше, там, не знаю, обходят этот чип, не нагреваются, работают каким-то признаком, прячутся в другом месте. И, в общем, нет теперь надежного способа, как изобличить, собственно, читера. Читеры обошли какой-то способ. Стоит ли доверять вообще вот, решениям, которые применяют, да? То есть стоит ли они там...
Trust the solutions that are used, such as the server solution for cheating software. Are those server-based solutions really secure, allowing to aggregate information? What does the server do? It collects user stats, it can compare game results, it can compare gamers, their statistics, deviations from their typical stats. Well, it cannot be broken. A server-based cheating software cannot be broken, because for this you need to crack the server itself. The worst point here
как я говорил, то есть он не коннектится к клиенту. По сути, если вы читите умно, да, как-то нечасто, редко, но метко, то, собственно, вот пример с велосипедистом, можно, по сути, не включать мотор, когда вы проезжаете около камеры, да, читить, когда это нужно, там, убить основного противника, а в остальное время играть как обычно. Статистика такого не поймает, и локально вы можете делать с игрой, что хотите. Да, то есть читы, которые убирают стены, убирают, показывают, где другие игроки сидят, они все еще возможны. У меня такой пример был, вот, знакомый мой один играет дома в какую-то игру, его недавно забанили. Причина оказалась простая. В его аккаунт садился иногда сын, играл, и статистика показала, что совершенно разная игра. Сын играл лучше, он получил бан в итоге. Он был очень недоволен, готов был отказаться от игры и перейти на другой сервер. И по сути это потери для того паблишера, который продавал ему аккаунт. Ну, что можно сказать про читы, которые локально работают? Они могут многое, если вы им позволите это делать, да? Ну, самое простое, это как бы они сканируют систему.
The simplest approach is about scanning the system. I'm always afraid of such things. When I'm playing, I don't want my system to be scanned. And it does not only scare me. All those cheating products, they make screenshots, which I don't like. I was interested in exploring how one pretty old cheating product worked. At a certain point of time, antivirus software started identifying it as a virus. So what did they do? They declared that they were antivirus software themselves. They said, just delete all the other antivirus products and use us. The biggest challenge for local cheating products is getting access to personal data, which are to be protected by various licensing terms and agreements. We're not keen about moving in this direction. In our work, we started from analyzing simple cheats, such as art.
Существует достаточно большое количество таких программ. К примеру, Cheat Engine имеет практически те же возможности, что и автоматик. А Game Guardian — это самый распространенный чит данного вида для Android. У этих читов есть только одно серьезное ограничение. Они не работают в мультиплеере. Потому что все критические данные хранятся на сервере, могут проверяться. И если изменить, например, количество жизней в такой игре, она не будет отражена на сервере, и, соответственно, какое изменение не получится.
Change the coding on the server.
Дальше мы рассмотрели продвинутые читы.
Then we engaged in considering exploring more advanced cheating products for specific games, allowing the gamer to have advantages that the other players cannot have. They grant access to normally concealed data. We have analyzed the cheat for one shooter that features an aimbot, allows locating enemy troops. On this slide you can see this cheat, the way it is seen by the user. You can see where the enemy troops are, their names, distances, their status, other objects such as first aid kits, weapons, rounds, and so on and so forth. On top of that, it features automated shooting. You can set it up in such a way as to make it shoot automatically, aiming at enemy troops' heads. You can do nothing, and it will be doing everything on its own, killing enemy troops. We decided to explore it. To understand it, we used process monitor, but we found out that cheat was using anti-debugging. And every time process monitor was used, the cheating software would identify it and shut down. Except for the fact that it was dependent on kernel 32.dll. Then we tried to analyze the memory. The memory of the game with connected cheat. We found out that there would be file variable pointing at the cheat's exe file on the disk. But unfortunately, we found nothing specific or useful. We also compared memory dumps with cheat and without it. We looked for the differences in the editor with the use of template, and we found out that most of the differences were in relocation sections only, which was in line with normal behavior. Proceeding from the results, we understood that the cheat was using traditional code intrusion method that works in the following way. The cheat is launched on behalf of the administrator, is included in the game, requests memory in the process of playing, records some code into the memory, and asks the game to execute it. As a result, we are playing a game with cheats incorporated in it. We decided to protect ourselves against that cheat in the following way. Firstly, we decided to add something to the executable memory. Should the cheat be introduced, it means that it would change we were checking their integrity in the process of playing every 5 seconds. However, we did not find any modifications. The integrity was intact, at least in the memory that we subscribed, which meant that either the cheat was working differently or that it was capable of restoring those sections of memory after penetration. Which led us to another idea. We decided to find out how the cheat was getting access to the required data. We took a debugger and decided to change the name of the game in the memory, which affected the information displayed by the cheat. We found out that at least the names of the players, of the gamers, were not stored by it. After that, we decided to change the sequence of fields in the class, and we found out that it affected the behavior of the cheat. It would stop working. Then we decided to encrypt those critical data in order not to allow the cheating software to understand them and to display them. and we see nobody here. We engaged in a short study to understand how much of the data should be encrypted to make the cheating software stop working. And we found out that at least the coordinates of the gamer's camera should be encrypted. We also encrypted the coordinates of the camera. And after several attempts to overcome the chip, I was banned. The cheating software was installed on my machine, and we thought that we were threatened. We decided to ask for the reason of being banned at the forum. On the next day, I came to the forum, but I did not find the topic with my question. Then I tried to start the cheating software, and I found it working, which means that I had been unbound in the same way I had been bound. After that, a colleague of mine decided to install the chip on his machine, and he was bound.
Of the methodology isn't that if in the original version the game had direct access to the critical data, then now we have of the game, and the game started to gain access to data through the trusted codes called Trusted Integrity Verification Module. So the game can't get the data unless it's corrupted. Well, if it's corrupted. And if somebody has corrupted it, such as hard money, then the trusted code informs the games about it. Now, more details about how this schematic works. In this case, the code is not encrypted, which it informs the trusted code what it's going to do, either to update the code in the memory or just to read. At step 2, the trusted code has to verify who has called it, what the calling function was. To do this, we need to sign the game using special tools, where we can see where the return address belongs, which range. And if it is indeed the game's calling game, yes, we can process the request. Otherwise, it could be just cheat and we say, sorry, but no. Now, once we've verified that it was a game function that called us, we start verifying the data integrity in the memory using the key. The integrity hasn't been compromised. We start executing the request. It is either to return the data if it's about a read, or to sign new data and write it back into memory, if it's in the case of write. To protect the key that's embedded into the trusted code, we recommend to obfuscate it.
Разные обфускаторы существуют, которые позволяют предотвращать таймперинг бинарей, изменений бинарников, также реверс инжиниринг предотвратить. Следующее по этой схеме хотел бы сказать, что
The next comment about this method is that this method protects the game from a simple cheat, such as art money. If art money goes here, then the trusted code will see the changes and will inform the game about it. The second schematic shows the operation of the method where we are encrypting the data. Here we use the key to encrypt and decrypt critical data in the memory. The difference from the previous schematic is that trusted code is responsible for encryption here, because in the first case it was only responsible for signing. It also obfuscates the code that has verified the code that has called it. And we also recommend to obfuscate the key. And this method allows protecting the game from advanced commercial cheats. And we're further going to show you a video how the game is used with a cheat and can be protected by our anti-cheat. The first and second method can be combined so as to protect yourselves from any kinds of tampering of data in the memory. The pros and cons of our anti-cheat method. Of the pros, I'd like to note that there are factors, like for instance the Valve advanced anti-cheat sometimes bans Valve anti-cheats sometimes ban those players who were not to blame. Our method does not conflict with the antivirus. Then we do not infringe on the confidentiality of the games. Of the minuses, I'd like to note the requirement for the refactoring of the game. Implementation is needed, integration of the cheat, and obfuscation, signing of some function that interact directly with the module. We have made our implementation of the anti-cheat using the Intel tools for obfuscation and compilation. We succeeded. And we brought it to the situation that the cheat stopped working. We understand that software protection is not so reliable because it works in the same domain as the user and the hacker. So we were developing this methodology, considering that modern hardware already protects hardware-based security methods, and that relates both to Intel CPUs and ARM. They're quite accessible, but the problem is that users are worried to get the latest model of the GPU rather than CPU. So maybe in the future, our methodology may be applied, maybe extended to hardware support. It fits it very well. Our understanding that the software that the anti-cheat contains is only a part of the overall cheat fighting strategy. It makes sense to take care that game developers should follow certain rules and recommendations and make cheat-safe engines, something similar to secure coding for a regular developer. Thank you very much for your attention. We are about to show you the video, perhaps the most exciting part of the presentation. So this is the first version of the video. When the game happens with a cheat that's up, it's not protected, just for you to compare as a benchmark. Sorry, mistake. It's a version. It's a protected version. Sorry about that. Let me go back to the unprotected one. So we're killed too often. No, not that. Sorry. And now you're going to see a cheat protected version. As you can see, the radar is empty. These are artifacts. Some remains of the cheat are still in the game. So that's it. Welcome. Welcome for questions, please. Please use the microphones. Thank you very much for the presentation. Have you seen the Blizzard games? How protected are they? No, we haven't. As far as I remember, Blizzard, there's a thing that we haven't talked about. It's called BattleNet. They recently had a row, saying they start asking of users, asking real IDs of users, to make it so that the game account should match their, physical address and the real person. They started very actively to push this. And then there was a row that one of the employees said, it doesn't matter, I can assign an address to anyone, and immediately all the information about them became available to everyone, where he lives, where he goes for shopping. No, we didn't look at Blizzard. They have some social engineering in their cheats, in addition to what I've said. They try to understand using your friends, who your friends are, if you're a cheater or not. If you're a cheater, then perhaps you carry a higher risk. Protections are basically the same with everyone, both server side and local side. The methods and approaches are not very much different. Everybody knows that. Thank you very much. You mentioned hardware protection methods, and you mentioned that there are already some in existence. Did you mean the enclave-based system that Intel is now implementing? I forget their code name or marketing name. Or did you mean something different? Well, ARM, as far as I know, has a system. I forget the name. Yes, Intel has enclaves, the so-called enclaves. The marketing name is different. So what's your specific name? Yeah, you can use that. Why not? This is memory protection and execution. And TPM, is it applicable? What? TPM, trust buffer model. I don't think that it has simple and easy public access. compared to enclave. What do you mean? All the specifications are open. You have to understand that we want to replace, let's say, software obfuscation by some hardware mechanism. TPM has executable code, VM, such as management engine, but I guess it's not an easy thing to get access to it. I mean, for a developer of an anti-cheat. So, explicitly no. For encryption, perhaps some of the things could be used, but I don't think that it's going to be much more secure than software-based methodology based on obfuscation. You have to understand that people who cheat, they own the system. They can debug the processes and get access to what they want. Did I answer your question? Thank you for your presentation. Can you tell me your methodology? Does it allow one to protect oneself from data spoofing? It's a server protocol that's going to be, so it's not just memory-based data modification, but rather packet-based consideration and modification of data at this level. So in the implementation that we have been sharing with you here, well, perhaps this methodology can be modified. When you're saying about the transmission of this data from one entity to another entity, you can establish between them a security channel, communication of this, keeping keys in both of these entities and encrypt the data as they're transmitted. Well, if the server is sending clear text data, it's clear the modified client will gain access. Yes, I got you. In this case, you need to encrypt the data on the server side, send them to the game, and then the game will be busy decrypting it. So it's outside the scope of this methodology. No. I mean, what I say is that our methodology can be modified to accommodate that. It all depends on the level of protection you want to achieve. Of course, we're not saying that our protection is like 100%, that our anti-cheat offers you 100% protection. Of course, any motivated cheater will be able to hack it. The other question is how much time they will need for that. So here, everything is based on the premise, on what tools you're going to use for obfuscation, for signing. If these are tools that are too difficult to reverse engineer, then you can provide a good level of protection. So in this case, the important thing is that nobody should steal your key. Thank you. There's another question about MPX, the enclaves. The question is, I'm not clear how to write the code for the enclaves, because as far as I understand it, it should be isolated, it shouldn't have dependencies to third-party modules. Do you need some special compiler for that, or how do you do that in real life? For instance, somebody wants to implement that in a game. How to use that? I'm not quite clear in terms of industrial development. Well, let me paraphrase. The name for enclaves is SGX, Secure Guardian Extensions. So basically, it's just regular code. The only requirement to this code is it shouldn't contain instructions. It's just normal C code without instructions affecting the processor mode, input-output, and there are some more restrictions. So it's clear that it's some code. But first thing that the compiler needs to know how to link it, assemble it, place it in a certain region of memory. Like, for instance, in Studio, I don't know, a GX compiler today accepts any code compiled by a regular compiler. So it's a special compiler. No, regular code compiled with a special compiler. With a so it's a kind of a linker. No, it's just loading a special CPU mode that has special entry instructions. It's similar to calls. Well, I know how it looks in assembler, in the assembly language, but what to do with dynamic memory? Do you need to have a special heap for that, or you can use the system heap for that? Usual methods are supported for memory allocation within the enclave, as far as I know. The only restriction is that I think it's 128 or 64 megabytes total for the system. So special API. No, regular API. So I can't take some boost. Can I use a boost in a component that will be in SGX, or will I need to use some special memory allocator, some special libraries for that? If you're writing a code for the enclave, you are using libc STL libraries that arrive together with the enclave. They're taken from a regular SDL port and FreeBSD libc. So those functions have been modified that are not supported by the enclave, such as screen print. But boost, no, you can't. Clear. Thank you. Look, you are saying that you encrypt the data. The question is, what happens if I modify your code? I'll patch it in such a way that it's going to tell always that the section of the code that's being executed is always valid. It's a good question. I can add a small detail to the description of our methodology. Trusted code does not only does encryption and decryption, it also does some useful work. Something for the game. Something mathematical. So correspondingly, if it all gets obfuscated, for instance, with an obfuscator that generates a self-modifying code, then, well, firstly, again, everything is based on the obfuscator that you use. If you are saying that you are always going to return the OK diagnosis, then it's either you've done some reverse engineering of the code, or you're just not calling the trusted code, having thrown it away. If you've thrown it away, we derive that this trusted code includes some useful computing, without which the game can't run. So it's worth mentioning or guessing that the true code should be executed. So therefore, you should change the true code. But true code cannot be disassembled. You're taking some returns, putting zeros instead of ones. So that's basically it. So it's a good question. It's a good question. Yes, you need some useful trusted codes, a valuable feature that would do something valuable for the game, so that without it, so the game couldn't exist without this module. May I ask you another question? Thank you for the presentation. I would also like to know about the cheater detection method. Can you modify your anti-cheat tool so much so that it should identify the cheat during the game and block the game if it should happen? Within this methodology, you can't. It just blocks the work of the cheat. It becomes useless. To do what you want, you need to use some system-based features. So to scan the system, and based on this information, you can get it. But otherwise, okay, thank you. Well, the only thing, we can block the operation of out money. We can notice that's there's a loss of integrity. But in this case, nothing really happens. It's just passive. Thank you very much for your presentation. And I now request you to pick two best questions, the one that you've liked the most, and award presents to their authors. We would like to offer this gift to the leader. Thank you for the question. And to the gentleman with a question of what happens if we change the module, modify the module, so they should always return the OK statement. Thank you very much. Thank you.